1, 2, 3 pi bonds, and a ring, that's 4, right? How many degrees on saturation does this molecule have? 1. How many does this molecule have?
1.
How many does this molecule have?
4.
4. Right? So it doesn't tell you the type of pi bond or ring, it just tells you that there is a pi bond and or ring, some sort of combination of pi bonds.
Wouldn't that be 5?
1, 2, 3, 4.
Oh, I saw that benzene. I thought it was attached.
I thought you said whenever we have 4, it's a benzene ring.
Usually when we have 4, it's a benzene ring.
Okay.
But we'll talk about that. Yeah. Okay. So Lily, hit me with some of the numbers here.
It's number 28 on mine. I have another question for the degrees of saturation.
Yep.
So it doesn't include O, but then when you're
Nope.
drawing your molecule, if you have an O molecule in and you have like a C double bonded to an O, does that double bond
Yes, it
count?
counts.
as one?
Yep, any pi bond counts.
Okay.
So it still counts. So O doesn't count for the degrees on saturation, but it still counts. Yep, the pi bonds still count. Why? Because it doesn't affect the saturation.
Because somebody somewhere figured it out, so that's why.
I can send you the, I can explain it more why. Okay. This is not absolutely important. What number do you have, Lily?
Number 28.
All right, hit me with some information. What's the molecular formula?
I'll give you the molecular
No
formula.
molecular formula. What's the mass spec data?
71.
It weighs 71 total.
That's just all it says. That's all it says.
Okay. What else we have?
IR, 3200, strong, broad, and 2250. And then in parentheses, it tells you that there's no absorption from 1500 to 2250.
So nothing else.
From 1500 to 2000.
All right.
And then for NMR, it's the HNMR. So we have 2.62, and that is 2 hydrogens. It's a triplet, and 6 hertz. And then we have 3.42, 1 hydrogen, broad S, eliminated by D2O shape.
Broad singlet, and the D2O thing again. So that should tell us what? Probably an OH or maybe an NH. Yep, okay.
3.85 and 2 hydrogens, triplet, and 6 hertz.
Is that it?
That's it.
Does it say anything else on mass spec? Does it say EI or anything like that?
Molecular mass, 71.
What number was it for you?
28.
So, 71, what does that tell us about the molecule? That's the molecular ion. What does molecular ion mean?
How much it weighs?
That's the mass of the whole molecule, right? That's the molecular ion. That's the mass of the whole molecule. So it weighs 71. You got a couple peaks here. 3200, strong and broad. What does that indicate to us either? That could be OH, NH, right? Those broad ones are OHs and NHs. We also have this one here that says a D2O shake, right? 1H. We probably think, right, these are A, B, C. We probably think it's going to be maybe an OH. Should we say there's going to be an OH? Let's say there's going to be an OH. And that H is HB. Squiggly lines, remember? Squiggly lines, we don't know what's bonded to the oxygen on the other side, right? We don't know yet. So that checks off this IR, right? Because what does IR tell us? IR tells us
Functional group.
functional groups, right? 2250. What does that tell us? 2250. Well, there's two things it could be. What is it?
SP.
2250.
SP3.
It's a triple bond region, right? So it's either going to be a CC triple bond or a nitrile triple bond. That's right. So it's either this or it's this, right? Rob?
Can you say from probably wouldn't work, the molecular weight is
Yep.
probably odd, so it's probably a nitrogen.
Right. So another little hint, right? If you have an odd mass, if you have an odd molecular ion, that also usually means you have a nitrogen. Right? That also usually means you have a nitrogen. Right? So what I would have told you on the test, maybe I said has nitrogen, right? We didn't really talk about the nitrogen at all. In your book, you should have read about it. But not everything, right? Again, it's college, not high school. Can't cover everything in lecture, right? So let's say it has a nitrogen. Which one do you want it to be then? A triple bond or a nitrile? Which one should we pick? Let's go with the nitrile, right? Let's say we have this. So we'll assume we have a nitrogen. So we have this piece as well somewhere. I don't know what's bonded there. All right, got that piece. So we've already checked off HB. So we've done this. We have a nitrogen. Checked off that one. We have A and C left. What do we know about A and C?
They're bonded.
They're split into each other. They're talking to each other, right? They're coupled. 6 hertz, 6 hertz. Right? So let's see what they would look like. Right? Each is for only 2 protons. So how many nearest neighbors? If you're a triplet, how many nearest neighbors must you have? 2. So one of these guys is going to be A, and the other one's going to be C, right? We still don't know what's bonded here. With me on this one? Now, we need to go back and do what? We've taken into account the splitting, the coupling constants, and the IR. Now we need to take a look back at what? What do you think we should look at?
Mass.
The mass? No, the mass we're close. I think we'll check the mass at the very end. Look at you. No, that's a good idea. Let's check the mass now. Let's check the mass now. It's a good idea. All right, how many? So we have an oxygen. We have 1, 2, 3 carbons. That's, what is it, 36? We have a nitrogen, 14. We have 1, 2, 3, 4, 5 H's. What does that come to?
71.
Comes to 71. Good. Right? That means we have all the pieces. Right? At least reasonably we have all the pieces. Right? So that means we've checked it. Right? So if you're doing this on the test, right, that'd be something good, right? If you literally did this and checked it, you get points. Right? Because it shows me you know what you're trying to do, right?
Yeah.
You know what you need to check. Okay. How do we want to put this together? How are we going to figure out how to put this together, right? This carbon, I have two open spots, I have 2 pieces. How am I going to decide which goes where?
It doesn't matter, does it?
Let's look at those frequencies and figure out shielding and de-shielding, right? If something's next to the OH, is that going to make it more shielded or de-shielded?
De-shielded.
De-shielded. So let's look at our frequencies now. 3.85, 2.62. So which one do you think is going to be next to the OH? HC or HA?
HC.
Which was more de-shielded? A or C? Which was more de-shielded?
C.
So which one should be next to the OH?
C.
Let's make C next to the OH.
Truly.
And the other side has to be the nitrile.
Oh. Yeah, but you have 16. So this has to be.
All right?
So if you multiply by 2, gives you 2, 12, 2.
Nope.
Which adds up to
Won't
16
matter.
hydrogens.
So stop now. Are we done?
Simplified division.
No. We always stop and check, right? We've already checked the mass, so that makes sense. We didn't add a carbon or hydrogen. But now does our splitting make sense? HB should be what? A singlet. Is it a singlet here?
Yep.
Yeah. HC should be a what? Triplet. Has two nearest neighbors. And it should be more D-shielded than A, right? Because it's closer to the oxygen. HA should be a triplet. Has two nearest neighbors for two hydrogens. And has 6 hertz, so it's coupled to HC. Yes.
On the test, will you want us to write A, B, C?
You don't have to write. You don't have to write A. I mean, this is all made up.
Because if you write A, B, C, it doesn't technically matter which side you put.
It doesn't matter. Yeah. I mean, you can, as long as you're consistent. If you do this, like this is the way. This is so. To be fair, guys, this is the way I do these problems. If you do them a little differently, that's totally fine. But I just want to show you how I like to work through these problems. You can do it a little differently, right? And you can do A, B, you can do 1, 2, 3. You can do A, you can do any letters. You can do X, Y, Z. It doesn't matter as long as you're consistent, right?
So when you're doing the splitting, it's you said that it's 3 bonds away, but so that doesn't count oxygen though?
Right, it doesn't count the OH.
Okay.
Right, because what's going to happen if you do a D2O shake? So this is a good test question. If this becomes a D, do we see D's in the proton NMR?
No.
If you don't see it, is it going to couple to anybody else?
Nope.
No. Right? So it also takes away the coupling. But also OHs and NHs really usually don't couple as well.
Okay. So it's 3 bonds away, but that has to be the carbon.
Yeah. But if you wrote it as coupling, that'd be okay. I wouldn't. Sometimes it does, sometimes it doesn't. It's just a little tricky. The OHs are. Okay? So we're going to get at least how to start these problems. The key is you got to start it. Right? You got to start. Yep.
Can you show me how HC is a triplet again?
HC is a triplet? How many nearest neighbors does HC have? 3 bonds away.
I don't know if you go from both the top and that's 1.
1, 2, 3. All right, so has 1, 2, 3. So has 2 nearest neighbors. So 2 plus 1, triplet. So make sure also though in this test, right? This will be one problem like this. Right? You gotta make sure. Remember we went through that study at the beginning. Make sure you know all that other stuff, right? Make sure you can explain how mass spec works. Can you explain how an IR works? How UV vis works, right? Do you remember what if you have more pi bonds? Is that going to give you a longer or shorter wavelength? Is that going to make it easier or harder to go from pi to pi star? Right? What happens in all these things as well? And make sure you don't get them confused. Right? This is only going to be one problem on the test. Okay. Promise.
Number 17, please.
You're 17?
Yeah.
Go quick.
So sometimes in the homework, instead of giving us the number of hydrogens, they give us the integration in random units. Will you do that on the test?
I'll give it. I'll give it. So the integration is relative, right? So if I said, right, this could be, right, when we say 2 and 1 and 2, I could have put, 6, 3 and 6. Right? It's all relative. And sometimes on the homework he gives you like 700 and 1400 and 700, right? So it's just a relative thing. Yep.
Couldn't you use that to also check too, like you have 5 hydrogens, does your that hydrogen?
Yes. Very good. Right? I can't have any more hydrogens than I have NMR signals for, right? So make sure here I have 5 hydrogens. I better only have 5 hydrogens in my molecule. Very good. Yep. So what number did you say, Promise?
Number 17.
Okay. Hit me with the numbers. What's the molecular formula? Somebody do degrees of unsaturation quick. What are the NMR signals? What are the data they give you?
Okay, so 1.26, frequency is 1.26.
Oh, slow down. Sorry about that. What number?
So the BPM is 1.26.
1.36.